Hey there, and welcome. Ever stop to think about what's really going on inside your head? We're about to pull back the curtain on the invisible world of tiny, powerful chemical messengers that are, quite literally, conducting the entire symphony of your life. Let's dive right in.
So let's just start with a huge question. What is it that's actually pulling the strings? What decides your mood when you wake up, your drive to get something done, or even just a simple twitch of your finger?
Well, the answer isn't some single master switch. No, it's way cooler than that. It's this incredible, buzzing, complex chemical network. I want you to picture a massive electrical grid with signals just firing out from these critical hubs, like the locus coeruleus you see here, and radiating out to influence every single corner of your brain and body. And the messages traveling along that grid, they're carried by what are known as your brain's chemical messengers. The scientific name for them is neurotransmitters. So what exactly is a neurotransmitter? In simple terms, it's a chemical that one nerve cell releases to send a signal to another cell. It's the most basic unit of communication in your entire nervous system. Think of it like a tiny message in a bottle sent across an incredibly small gap, telling the next cell what to do. Fire up, stay quiet, go faster, or slow down. Now, while there are a ton of these messengers, a few of them are the real A-listers. They're responsible for most of the main action. Think of them as the lead characters in the story of your brain. So let's meet them. First up, we've got acetylcholine, or ACH for short. Now, this one's a big deal. It has the honor of being the very first neurotransmitter anyone ever identified, way back in 1914. So yeah, it's a true veteran. And it acts like the conductor for a massive internal orchestra. And when I say orchestra, I'm not kidding. ACH is absolutely critical for everything from the conscious decision to move your arm to all the automatic stuff that keeps you alive without you thinking about it. But it doesn't stop there. It's also essential for forming new memories, for learning new things, for paying attention, and even for managing your REM sleep, which is where your brain processes all that new info. So you can imagine when this ACH system goes wrong, the consequences are pretty serious. In a condition called myasthenia gravis, the body's own immune system attacks the ACH receptors on muscles, causing profound weakness. And sources also show a really strong link between low levels of acetylcholine and diseases like Alzheimer's and multiple sclerosis. All right, let's move on to our next character, and this is one I'm sure you've heard of. Dopamine. It gets called the pleasure molecule all the time, right? But that's not quite the full story. It's actually more accurate to call it the motivation molecule. It's the chemical of desire, the drive that makes you go out and seek things. Dopamine is that little kick that makes you want to check your phone, or that feeling of yes when you finish your project. It fuels our drive, gives us that sense of reward, helps us focus, and boosts our mood. And just like acetylcholine, it also plays a massive role in controlling our physical movements. And this really drives home just how critical that motor control function is. Parkinson's disease is the direct result of dopamine-making cells dying off in a key part of the brain. Without enough dopamine, the brain's ability to send signals for smooth, controlled movement is severely damaged. Okay, our third key player is serotonin. Now, if dopamine is all about the wanting and the seeking, serotonin is often thought of as being about contentment and well-being. You can kind of think of it as the brain's great mood stabilizer. Its theorized roles are huge, helping to keep our moods on an even keel, creating a sense of well-being, and contributing to feelings of happiness. It also helps with our sleep cycles. And get this, a huge amount of our serotonin isn't even in our brain. It's in our gut, where it's a key player in digestion. Just goes to show you that deep, deep connection between the brain and the body. So, you've met the main players. But here's the thing. The secret to a healthy brain isn't just having these powerful chemicals. It's all about having them in the right balance. Too much or too little of any one signal can throw the whole symphony way out of tune. This brings us to a pretty intense concept called excitotoxicity. You know how some neurotransmitters are, well, excitatory? Their whole job is to shout, go or fire to the next neuron. But what happens if that signal gets stuck on repeat? The source explains that certain substances can make neurons fire so fast and so often that they literally burn themselves out, leading to damage and even cell death. And a prime example of a potential excitotoxin discussed in the source material is monosodium glutamate, or MSG. But here's the catch. If you're trying to keep an eye on it, you have to be a bit of a detective. It's often listed under other names, like yeast extract or the super vague natural flavor. It's still the same active component, just flying under a different flag. So if this system is so finely tuned, so delicate, how on earth does the brain manage it all? How does it control this nonstop chemical conversation? Let's take a look at the mechanisms that fine-tune these signals. Okay, to get this, picture a receptor on a brain cell as a little lock. The natural neurotransmitter is the key that fits perfectly. An agonist is like a master key. It's a different substance, but it also fits the lock and opens the door. But an antagonist is like a key that fits in the lock but then breaks off, jamming the little thing up so the real key can't get in. But what's even crazier and honestly amazing is that your brain can also just change the number of locks on the door. If a signal is too quiet, cells can add more receptors to listen harder. That's called upregulation. And if a signal is just screaming too loud, they can pull receptors away to protect themselves. That's downregulation. It is literally the brain's own volume control, and it's the biological basis for how we develop tolerance to things. This all leads to the big question: how do we influence a system when it's out of balance? And the sources really point to two main paths. You've got the pharmaceutical approach, like SSRI medications, which work by blocking the cleanup crew for serotonin, leaving more of it available. And then you have natural approaches, things we can do every single day, like getting exercise, some sunlight, and connecting with people, which can also have a really powerful effect on these exact same chemical systems. And this is where it gets really exciting, because it leads to this incredibly empowering idea. We are not just passive passengers in our own brains. The choices we make day in and day out mean that we are, in a very real way, the architects of our own brain chemistry. Let's start with the basics, the building blocks. I mean, you can't build a house without bricks and wood, right? Same thing with your brain. To make serotonin, for instance, your body needs an amino acid called tryptophan. And where do you get that? From foods like eggs, fish, and nuts. You are literally eating the raw ingredients for your own mood. And it goes way beyond diet. The sources point to some really simple but incredibly powerful actions. First, get moving. Exercise is like a natural pharmacy, releasing endorphins and other feel-good compounds. Second, get outside. Sunlight isn't just for vitamin D. It can also trigger the release of those endorphins. And third, reach out. Social connection, even something as simple as a hug, can boost hormones like oxytocin that build our bonds and help buffer us from stress. So here's the big takeaway. Your brain isn't some fixed piece of hardware that you're stuck with. It's a dynamic, living system that is constantly adapting and rebuilding itself based on the inputs you provide. The chemicals are the messengers, sure, but you have a hand in writing the messages. So the question to leave you with is, what are you going to give your brain to work with today?